For the first problem, we have a mass that is oscillating with a spring attached to a spring. With a mass of 2 kilograms, a force that is required to move it, about 20 newtons, and it's moved a distance of 200 meters. And then we have the next question. First, we need to determine the spring constant, which is given by the formula, which is, we have the force, it's 20 newtons over the distance, which is K, it's equal to 100 newtons over meter. Then we are asked to find out the frequency of oscillation. With the formula for this, we know that the formula is like this. So we have all our values: 100 over the mass, all this to the square root, and we find out that the acceleration, the omega, is square root of 50. And then we have that also omega is equal to 2 pi times the frequency. So we need to isolate the frequency here, and frequency is equal to omega over 2 pi, which is square root of 50 over 2 pi, which gives us a result of 1.13 hertz. Then we are asked to find out the maximum speed and where does it occur. So we also need the next formula. The maximum speed. So we have the value that the distance that it's translated the block or the mass, it's equal to its maximum amplitude times omega, which was square root of 50. By multiplying this, we obtain that the speed it's equal to 1.41 meters over second. And then the next point is to determine the maximum acceleration. That it's equal to amplitude times omega squared. We do the following, also multiplying the amplitude 0.2 times square root of 50 squared. So we determine that our acceleration is 10 meters over second squared. Then the total energy in this system, it's given by the formula 1/2 of K amplitude squared. Of the K, it's 100 newtons over meter times its amplitude squared. And the energy, final energy, it's equal to 2 joules. And for the last question, we are asked to find out the speed and acceleration when it is equal to 1/3 of its maximum value. So we know that the energy, we are going to do this question by conservation of energy. And this energy can be decomposed into 1/2 of k over x squared plus 1/2 of the mass times the velocity squared. So we know that here our x is equal to 1/3 of 0.200, and it's our amplitude or the distance. And by solving this, we obtain that the velocity is equal to 1.33 meters over second, and the acceleration is given by w times x. And also by solving this, we know that it's equal to 3.33 meters over second squared.